I'm going to talk about QMap, Voluntary Engaging Students in Question Generation and Prerequisite Linking. I'm Imania Kizare, and I've co-authored this paper with Tirdad Bari and Professor Paul Resnick. Generating multiple choice questions and peer evaluations of them is known to improve a student's critical thinking and deep learning. Visualizing relationships between concepts enhances meaningful learning. The student's ability to relate new concepts to previously learned ones. We designed and deployed a collaborative learning process through which the students generate multiple choice questions and represent the prerequisite knowledge structure between questions as visual links in a shared map using a variations of concept map that we call QMap. For this study, we prototyped QMap using a combination of Draw.io and Slack. We conducted a 4-month study with 19 undergraduate students who collaboratively studied Python, HTML, and CSS languages. The students sustained voluntary contributions, creating 992 questions, which were identified as high quality by the instructor, and draw 1,255 meaningful links between the questions. Through the analysis of self-reports, observations, and usage data, we report on the technical and social design features that led the students to sustain their motivation. Walkthrough and rationale. We asked the students to study the topics of the week on their own and look for anything valuable to teach their peers. Then they design multiple choice questions with an intent to help their peers learn what they find valuable. Here you can see 2 paragraphs of one of the textbooks about Python programming that we collaboratively studied. One of the students took the second paragraph and designed this question: why should mutable objects be avoided to be used as values of an optional parameter? So there's a multiple choice question. Here's the procedure a student went through when designing a new question. They started with writing the question stem. Then they added the link to the reference from which they designed this question. Then added another correct choice accordingly based on what they learned from the reference. The student was not satisfied with this explanation in the textbook. They found a Stack Overflow thread about this topic and cited it and added another correct option. Next, the student started thinking about misunderstandings and confusions and added wrong choices. For each wrong choice, they added choice-specific feedback to inform others about their misconceptions and how to solve. Multiple choice question generation by students positively impacts the students' self-confidence, finding different ways to solve a problem, exhilarating students, facilitating peer evaluation, metacognitive thinking, critical thinking and evaluation, recognizing misconceptions, and innovating new solutions. The last 4 are characterized as ingredients of deep learning. Numerous studies have reported these benefits through experiments conducted using a popular question generation platform called Peerwise. One of the main differences between our design and other MCQ generation systems is a shared map where students draw prerequisite links between questions. The student navigates through the shared maps of existing MCQs and prunes forward to reach the related topic and find the necessary MCQ that other students should learn first to be able to learn the new MCQ. Here the student starts from the question, what kind of data types are used in Python? Among the possible pathways forward, they choose functions, choose all that apply. Among the child nodes, they look at the next level node and they choose how do you invoke a function, and they continue with optional parameters. Here we go. They found the necessary prerequisite question. Note that the students over time develop a virtual image of different areas of the map in their mind, and they don't start every time from the root node to find questions on the map. In addition, they can use the search tool to look for their desired questions on the map. After finding this question, the student creates their new question as a child node under it to inform other students that they should learn it first to be able to learn the new question. After finding the prerequisite question, the student creates their new question as a child node under it to inform other students about where the question is located and what to learn first before it. And they relate these 2 questions using a linking phrase to explain the relationship. After adding the new question, it will be in the open state. Whoever wants can close it and only keep the question stem. to take less space on the map. Clicking the button again opens the question. While question generation is shown to improve a student's deep learning, we intended to also enhance their meaningful learning, which is known to be the foundation of creativity. Joseph Novak designed concept mapping, and through longitudinal studies showed significant improvement of meaningful learning when visualizing relationships between concepts in hierarchical structures. After creating the question on QMap, the student should immediately post it on a Slack channel to claim its ownership. This means from now on, the community sees the name of the student on the question wherever they vote and comment on it. When navigating throughout the map to create new questions, if the student finds a very similar question, they're not allowed to create duplicate or redundant questions. Otherwise, the community downvotes their redundant questions. So instead, they basically evaluate the existing similar question and vote or comment on it. Votes on each question build a reputation in the community for that student, indicating how helpful the student has been to the other members of the community. In addition, there is a specific vote that the instructor admired the very high quality contributions. In addition, the students and the instructor can also comment on each question to ask or answer questions, express their concerns, or discuss the content and relations of any question. As you see in the right thread, the instructor has asked the student about the MCQ generated by one of the students. The student realized their mistake and explained how they corrected it. The instructor further explained the case by giving students some suggestions. In our study among the students and the instructor, editing an MCQ was referred to as claiming the MCQ, and the last person who had claimed it was referred to as the owner of the question. This further incentivized not only improving MCQs, but also creating high quality ones. In this example, the MCQ was previously created by a student B, and a student A improved and claimed it. Importantly, as a requirement for claiming the ownership of the student B's MCQ, the student A was supposed to post justifications or reasoning for their edits. This would help a student B understand their possible mistakes and why and how their MCQ was modified. One of the interesting observations was that the students appreciated improvements on their MCQs by upvoting the claims. Self-determination theory advises to give students less extrinsic motivators and more autonomy to encourage their intrinsic motivation to learn. However, in most studies, the students' motivation to voluntarily generate MCQs typically declines after 1 or 2 weeks. Denny et al. In 2018 conducted a controlled experiment where they incentivized the students to voluntarily generate questions through points, badges, and vote. But none of these conditions of the experiment had any significant effect on question generation attitudes. When voluntarily contributing, some students may exert social loafing to use the map of MCQ generated by their peers without contributing to it. The collective effort model suggests several factors that may reduce social loafing when collaboratively producing public goods. We employed CEM suggestions in generating, evaluating, and improving or claiming questions. Now, looking at the evaluation of the results. Over 4 months of the study, 19 students voluntarily generated 1,154 questions. The average number of questions per week declined gradually, but it still averaged more than 3 questions per student, even in the last few weeks. Note that when the map got larger, it was more challenging to create questions that were conceptually distinct from the existing questions on the map. The average number of instructor upvotes and the special votes to admire high-quality questions increased over time, indicating a gradual enhancement in the quality of MCQs. Our primary source of evidence is qualitative. We observed behavior throughout. At the end of the study period, we collected open-ended individual reflections and conducted a retrospective group reflection session. For the individual reflections, we asked the students to fill out an anonymous Qualtrics survey with 13 open-ended questions. 11 out of 19 students filled out the survey. Each prompt asked the students about possible alternative designs for one feature that they experienced. Novakian concept maps have a hierarchical structure. However, they do not define any constraint on the alignment of nodes. Early on, we realized that without such a constraint, the map gets too messy to navigate through. As a solution, we asked the students to align nodes And same with columns. The students found MCQs, especially the requirement to find and draw prerequisite relations on the map, to be helpful. 3 students explained that it helps because you can quickly locate similar questions. By seeing all the connections and nodes, the students are given a sense of pride and purpose and are motivated to collaborate to grow the map. When students move nodes wherever they like, it creates a more messy concept map. The students improved and claimed 134 MCQs posted by others, 11.6% of the total. In a few other cases, the revisions made the MCQs were evaluated as worse and the instructor reverted them. And a student explained it was a great system to reward the students who spend the majority of their time improving others' questions. Without this process, these students' participation would have been underrepresented. In terms of comments, the instructor identified 218 or 19% of them as constructive feedback. In addition to showing students a chronological log of generated MCQs, Slack also notified the students of new contributions. One student wrote, "It helps the students keep track of modifications on each map and understand peers' reasoning for changing a question." Another one explained, "Being able to see other students encourages communication that is vital to the project. The students who can see the contributions of others will better contribute to the project themselves." In the group reflections, the students appreciated progressive assessment of their learning based on the quality of generated questions. A student explained the instructor was able to survey the students' understanding of a topic in general and able to help if the whole group was struggling with a specific topic, rather than the students just feeling lost when they didn't understand something. Future work and conclusion. Going back and forth between Draw.io and Slack in our pilot study was confusing. The fact that the students were able to maintain motivation despite the suboptimal tools is a further testament to the value of the learning process. To better support QMapping in the future, we are now developing and integrating our 2 subsystems into a unified web application to make it easier for students and instructors to interact with the system and each other. Conclusion. To recap the most helpful collaborative learning activities we found in this study, the students voluntarily generated and shared their MCQs on a map. Importantly, with the objective to facilitate learning for their peers, not themselves. They draw prerequisite links to inform their peers about the order of learning MCQs. Progressive assessment was purely based on helpfulness of generated questions to peers, and students had to reason for their edits on others' MCQs. Thank you.